The 23rd element on the periodic table of elements is vanadium. This is Norris Teaches Science today with another physical science edition video with me, Mr. Norris. Today we are going to talk about acids versus bases. So the goal of this video is that you can say I can explain the difference between an acid and a base. So what is an acid? The full definition of an acid is a compound that produces the hydronium H plus ion when dissolved in water. The best way to know if something is an acid is if you look at the chemical compound formula and you see that it starts with the letter H, or the element hydrogen. So acid properties, one property of it is that some acids you can eat and they taste sour, like Sour Patch Kids or oranges. They have a sour taste to them. They do react violently with metals. Acids can eat away at metals. They are an electrolyte, which means that they can conduct electricity. And one thing acids can do is if they're strong enough and they come in contact with your skin, they can burn the skin. Can even take off a finger, dissolve the body, stuff like that. Common acids out there are like hydrochloric acid, which is HCl, sulfuric acid, H2SO4, nitric acid, HNO3, citric acid. This one doesn't start with H, but it's C6H8O7. Or acetic acid is another one that doesn't start with the letter H, but it is an acid, CH3COOH. Right, a base, on the other hand, is the opposite of an acid. This one is a compound that produces hydroxide, OH minus ions when dissolved in water. So when you're looking at the chemical formula and it ends in OH, it's a base. OH stands for hydroxide. Some base properties are that some of them taste bitter. Most of your shampoo and soaps, they're more base products. I know when I was a kid and say I talked back to my mother that I had to have my mouth cleaned out with soap. Soap tastes bitter, just so everyone knows if you've never had to eat soap. They do have a slippery feel to them. A lot of things about your cleaning supplies, they have this slippery feel to them when you encounter them with your hand. And some, if it's strong enough, some bases will burn the skin as well. Think of like bleach. Bleach will burn the skin. Bleach is the base. So some common bases out there that are not like household chemicals are calcium hydroxide, Ca, parentheses OH, close parentheses 2, magnesium hydroxide, which is Mg, parentheses OH, close parentheses 2, or sodium hydroxide, NaOH. So how can we determine if a compound is an acid or a base? Well, this first way is if we're going to look at the formula. So acid's formula will start with H, or hydrogen. Base's formula will end in OH, hydroxide. If it doesn't do either of them, we consider it a salt. So let's do a little practice here. So this first one, number one, you're going to ask these questions. Does it start with H? Does it end in OH? Or if it doesn't does it do neither? So the first question, does it start with H? Well, no, it doesn't have H at the beginning. Does it end in OH? Yes, it does. If it ends in OH, it's a base. Number two, does it start with an H? Yes, it does start with H, so it's an acid. Next, number three, does it start with H? No. Does it end in OH? Well, it doesn't do that either. It does neither, so it's a salt. Pause the video real quick. Can you figure out the other three? I'll start again in 5, 4, 3, 2, 1. All right, let's do number 4. Does it start with H? No, it starts with N, so it's not. Does it end in OH? Yeah, actually it does, so it's a base. All right, this next one, does it start with H? No H in the beginning. Does it end in OH? No H at the end, so since it does neither, it's a salt. Last one, does it start with H? Yes, it does start with H, so that means it's an acid. Now, Remember, we talked in a different video, if you've watched them in the series, we talked about there were two special reactions, combustion and neutralization. I didn't cover what a neutralization reaction was in that video because you had to know what an acid and a base was. So a neutralization reaction is when you take an acid and you combine it with a base. And the result will form a salt. See how it says a salt, not always salt when you think of like NaCl, but a salt, anything that doesn't start with H or end in OH, and it's going to produce water. It's also a double replacement reaction when doing this. So we look at this equation down here, HCl is the acid, and NaOH is the base. The Na and the Cl will combine together to create your salt, and your H2O is your water. And so this is a neutralization reaction. Now, water could be written like this, or you can write water HOH, because that's where this OH comes from and this H comes from, just to talk about the neutralization reaction. Now, when we talk about acids and bases, we do need to talk about something called the pH scale. It is a number line, and it goes from 0 to 14, and we use it to determine how acidic or basic something is. The middle of the number line is 7. Numbers leading up to 7 are acid, numbers leading away from 7 are a base. So an acid's range is somewhere between 0 and 6, with your strong acids 0 to 2. So if something has a pH of 1, it's an acid, and it's a strong acid. All right, bases range from 8 to 14, with the strong bases being somewhere between 10 and 14. And water, pure water, has a pH of 7, and we call 7 neutral. Now, we do have some indicators where we can actually test in a chemical aspect if something is an acid or a base. The first two indicators are something called blue litmus paper and red litmus paper. Blue litmus paper is like is what you see down here at the bottom, right here, is a little blue slip of paper, and you dip it into a solution. If the blue litmus paper changes to red, then it's an acid. But if there's no change, it's most likely a base, but it could be a salt or water. Red litmus paper is a piece of red paper, and you dip it in the solution. If it changes from red to blue, then it's a base. If there is no change, it's usually an acid, or it could be water, or it could be salt. It's just not a base. Then we have something called pH paper. This is a slip of paper. It's usually about yellowish. You dip it into a solution, and then you compare it to a little key, and it tells you if it's an acid or base. Most times, if it turns red, orange, or yellow tint, it's an acid. If it turns something like blue-greenish tint, it's a base. Then we have something called phenolphthalein. Phenolphthalein. So you have a solution, and you don't know if it's an acid or base. You take phenolphthalein and you add it to the solution. If the phenolphthalein stays clear, then it's an acid. But if the phenolphthalein turns hot pink, like you see in this picture here, it's a base. And that's a little bit about acids and bases and how they factor into chemical reactions at the same time. I hope you learned something today. Come back for another video. And like always, I'm Mr. Norris, and I'm signing out of this video.